Okay, this is lesson on evaluating expressions. We're just gonna go ahead and get started. A bike shop charges by the hour to rent a bike. Related items are rented for flat fees. So like a bike, you gotta like pay $12.50 per hour. The helmet, lock, and basket you pay for once, and it's yours until you bring the bike back. Write an expression that represents how much it will cost to rent a bike and a helmet for 8 hours. And then how much would it cost to rent a bike and a helmet for 3 hours? Solve this problem any way you choose. Okay, so go ahead and try to figure it out. Okay, two-part question. We've got to write an expression and then figure out what 3 hours cost. So what would be an expression to represent the cost of renting a bike and a helmet for 8 hours? Maggie, what do you want? 1250 times 8 plus 525. Because the helmet costs 525. Okay, you could have wrote $5.25 plus $12.50 times 8. But I'll tell you, like they typically put the part with the variable first, and then the constant after. Also, the problem said bike and then helmet. So this actually describes the bike and then the helmet. So just following the order. Okay, so that's the first part. Then they want to know how much it would cost for 3 hours. What do I do to figure out what it would cost for 3 hours? Yeah, multiplication. What am I multiplying together? 3 and which other number is up here? 1250, yeah. So I'm going to take out the dollar signs right now. And then this 525 stays the same. Okay, so we need to do order of operations, which says multiplication first. What is 5 times 3? 2 times 3. What's 1? 1 times 3. Where does my decimal go? Negative. Half to 7. Okay, and then I'm going to add the 0 because it's really $37.50 plus 525. 5 plus 2. 7 plus 5. 1 plus 3. So it would cost $42.75 to rent the bike for 3 hours. Which that's kind of expensive. That's like halfway to owning your own. Actually, I don't know how much price it costs. They used to be around $100. Yeah. Okay. Now, we wrote that expression. You didn't necessarily need to have the expression. You probably could have solved that on your own without the expression. But we were able to write an expression to represent what you're doing, and then we solved it. We evaluated it. This is what you're doing today. It's exact stuff. Plugging numbers in for each. Okay, when you put in a value for each, or n, or x, or whatever variable, that variable goes away. Okay, that's something that the older kids struggle with. We want to keep that variable in the top. So it just replaces it. So like here was an 8, here's a 3. That h is gone. Okay.
How can you evaluate an algebraic expression? Let's find out. Eric collects miniature cars. He has one large case that has 20 cars. He also has 3 same-size, smaller cases filled with cars. Let n equal the number of cars in each smaller case. Remember, a variable can represent an unknown number or any number in a set of data. Then the expression 20 plus 3n represents the total number of cars that Eric has.
Okay, so because of the you can see a picture and it shows cars in the smaller case, but if you didn't know, you couldn't see the case itself. They told you there was 20 cars in the first case, and then he has 3 cases that are exactly the same. So that's why right now they have 3n there.
How many miniature cars does Eric have? If each smaller case holds 10 cars, 12 cars, 14 cars. Let's look at the expression. 20 represents the number of cars in the large case. 3n represents the number of cars in the smaller case. What do you need to do? Evaluate 20 plus 3n when n equals 10, 12, or 14. To evaluate an algebraic expression, use substitution to replace the variable with a number. Substitute 10 for n. 20 plus 3 times 10. Why do you multiply 3 by 10 before you add 20?
Why do we take 3 times 10, Miss Anna? Absolutely, yes. Multiply before you add. So you take 3 times 10, not 23 times 10. 23 times 10 would be a lot more cars.
The order of operations says to multiply first. 20 plus 30 equals 50. If each smaller case holds 10 cars, Eric has 50 cars. Now substitute 12 for n. 20 plus 3 times 12. 20 plus 36 equals 56. If each smaller case holds 12 cars, Eric has 56 cars. And finally, substitute 14 for n. 20 plus 3 times 14. 20 plus 42 equals 62. If each smaller case holds 14 cars, Eric has 62 cars. Each evaluation of the expression is the same because 3 is multiplied by a number and then 20 is added to that product. How is each evaluation of the expression different? The value substituted for the variable changes, so 3 is multiplied by a different number each time. The table summarizes the values of 20 plus 3n for each number of cars. Do you know what the numbers in the second column represent? The values of the expression when n equals 10, 12, or 14. They represent the total number of Eric's cars.
Oh, they already did this, yeah. Okay, move on.
Can you tell what the numbers in the last row mean in context of the problem? They show that Eric would have 62 cars if there were 14 cars in each of the smaller cases. Now you can evaluate an algebraic expression.
What's nice about expressions with variables in them is that you can plug any number into them. So in this case, they use 10 and 12 and 14. But the process of solving was exactly the same. So once you plug in a number, you can like take it back out and plug in a new number. That's why they did a 10, a 12, and a 14. Just because you plug in a 10 doesn't mean like that's the only way to solve that problem. Okay. So let's look at this. Our algebraic expression is 50 minus t, and we want t to be 10, 20, or 25. And then we'll like put everything into the table at the end. Okay, so I'll just plug in our 10, 20, and 25 into a little box. So our first one will be 50 minus 10, then 50 minus 20, and then 50 minus 25. What does 50 minus 10 equal? 40. What does 50 minus 20 equal? Josie? 30. And what does 50 minus 25 equal? Matthew? Okay. Okay, and then I'm just gonna put those answers up here in the chart. Okay, so what this chart says is when t is 10, this expression has a value of 40. When t is 20, the expression has a value of 30. And when t equals 25, this expression has a value of 25. Okay. What does it mean to use substitution to evaluate an algebraic expression? What are we substituting when we solve? Yeah. Yeah, you substitute the letter and the number. So the letter goes away and number takes its place. Okay. Julia's family took a 4-day trip. Julie and the mother wrote an equation to calculate their gas mileage, M, in miles per gallon. Let D equal the number of total miles driven on the trip, and let G equal the total number of gallons of gas used for the trip. So we have an expression, and this one's an equation. M equals D divided by G. And then they asked what the gas mileage was for the 4-day trip. Okay, this is the equation because it has the equal sign in the middle, but it also involves 3 variables. No numbers yet, just variables. Okay, a lot of equations that we work with in science or area, volume, those kind of equations have multiple variables in them. Okay, but they told us exactly what each variable stood for. Can we find the information we need by looking at the chart? Okay, we have, let's see, gas mileage was M. D is total miles driven. And G is the total number of gallons. Can we find all that information from our chart? Or at least enough to solve the problem?
Yes.
Yes. Okay. Do we know the mileage? No. Do we know the total number of miles driven?
Yes.
Yeah, we can figure that out. Do we know the total number of gallons of gas used? Yeah. We have to still find the totals, but that information is right there on the chart. Okay. So we will start with the total number of miles driven. And I'm just gonna cheat and use that as my problem. So I'm gonna add all of these together. What is 6 plus 9? Plus 2? Plus 3? 2 plus 7? I should have a different one. Okay. 7 plus 3? 10. 8 plus 2? 10. Okay, that's 20. 20 plus 6? 2 plus 4? Plus 4? Plus 3? Plus 2? They traveled 1,560 miles in 4 days. That's a lot. Okay, that was our distance, and that's on top of the fraction. Okay. Then we're going to figure out how much gas they use. 5 plus 4. Plus 1. 5 plus 5. 10 plus 6. Plus 3. 19 plus 1. 2 plus 1. Plus 1. Plus 1. Plus 1. They use 60 gallons of gas. That's our G, and that goes on the bottom of the fraction. Oh. I'm just going to write G. All right. Or 60. Okay. Then I have something that I can solve, right? Or simplify. I can take 1,560 and divide it by 60 to figure out our mileage. So let's do that now. How many times will 60 go into 156? 2. So 6 times 2 is 12. So 120. How many times will it go into 360? 6. Yeah. So if you look at like the non-zeros, 36 and 6. It's going to be 26. And they told us mileage is in miles per gallon. So if you want to label it 26 miles per gallon. So on this one, we would have to do a little bit of calculating first. Then we put the numbers into the expression or the equation and solve. Okay. Instead of them telling you the numbers, you've got to put the numbers where they belong. So like an extra step. Okay, I'm guessing the next couple pages are just going to work through that. Yeah. So they added everything up like we did, plugged it into the equation, and solved. We got 26, which is what we got, which is good. I like when we match. Okay. Now we have an expression 3.4 plus 12 times A divided by 4. And we want to evaluate when A equals 10. Okay, and it's important here that you show multiplication in some way, because if not, it would look like the number 1,210. And you can use parentheses, you can use any of the multiplication symbols, but just because these are right next to each other doesn't mean the numbers are right next to each other. They're being multiplied, okay? So what in this problem am I gonna do first? And 12 times 10, what is 12 times 10? Yeah, 120. Now what am I gonna do? Marco? No, there's something else you should do first, Megan. Yep. Multiply and divide first. So we gotta divide next. Okay, if I have 12 and I divide it by 4, what is it? 3. So oops. So that 0, we gotta add a 0 to the end. So we have 3.4 plus 30. What is 3.4 plus 30? Anna? No. No, okay, if we line them up, 30, there's my decimal. What would be that? 33.4, good. Okay, that's not the only value the expression can have. This depends what A equals. But when A equals 10, all of this math stuff up here equals 33.4. Okay, you would do the exact same process no matter what A would be. You would multiply, then divide, then add. Okay, so I think there are some where they're going to say, here's the problem. Plug in this number, and then this number, and then this number. Okay. Mr. Grant wants to tile a 27 square foot area with square tiles. Let S equal the side length in feet of a square tile. Use the expression 27 divided by S squared to find the number of tiles Mr. Grant needs to buy. Okay, so they're telling you the exact expression you need to use. 27 divided by S squared. And then in the picture, you can see that these tiles have a side length of 1/3. Okay, so we can take that 1/3 and plug it in and substitute it for X. So when we substitute, we have 27 divided by 1/3 squared. And we need to do the exponent first. So 1/3 squared is the same as 1/3 times 1/3. And that equals 1/9. So now I have 27 divided by 1/9, which is the same as taking 27 times 9. We have 243. So he would need to buy 243 tiles to tile the area he needs, whether it's a bathroom or a walkway or a random spot in the middle of his living room. I don't know. You would need 243 tiles. Okay, suppose Mr. Grant decided to buy square tiles that instead have a side length of 3/4 of a foot. How how many of these tiles will he need to buy? Okay, the 21, 27. Yeah, 27. Okay. So the expression stays the same, 27 divided by x squared. But this time, instead of 1/3, we're going to plug in 3/4. Okay. What do I need to do first? Yeah. Yep. Okay, that's so we would have 3/4 times 3/4. So it's 3 times 3. 9, 4 times 4. 16. Okay. This division problem is the same as 27 times 16 over 9. What's that called when I flip the fraction around? That's the reciprocal. Okay. So that's like a 27 over 1. We're going to take 27 times 16. Do you know that one off the top of your head? Me neither. 7 times 6. 42. 2 times 6. Plus 4. And then we can say 11 and 2. 6 plus 7 is 13. 1 plus 2 is 4. Okay, so when I multiply across here, I get 432 over 9. You think I can simplify that? Probably. Survive. How many times will 9 go to 43? 4 times. How many times will 9 go into 72? 8 times. They don't count either. So this time he would need to buy 8 tiles. Okay, the tile itself is bigger, so he has to buy less. So your answer makes sense. Okay, if you had more than that, like if you have 500 tiles, or if you didn't divide by 9, you said 432, because when it's bigger tiles, you should not have to buy that. Okay, any questions? Lots of different ways you can use the variables and solve problems. Okay, let's show you an example of an expression with 4 different variables, A, B, C, and D, and then they plug in the values listed on the top. And then they solve using the order of operations. So these 4, what I was talking about. They're going to give you an expression, and then they're going to give you multiple, I guess they just have multiple variables, and then you plug them in. So every time you see a T, you're going to replace that T with a D. Every time you see a Q, you're going to go with Every time you see an X, you're going to replace it with a Z. Okay, so let's look at number 6. Okay, 6 times W. Okay, what's W? 1/2. Okay, and then that's divided by X plus X. 3 plus X. What's the first thing I do? Don't play. What is 6 times 1? 1 times 2. 6 over 2, or 6 divided by 2 is 3. 3 divided by 3 plus 9. Divide, what's 3 divided by 3? 1 plus 9. Okay, the solving shouldn't be anything new, it's just making sure you look in the right value. Okay, let's do 7. T squared, what's T? T squared minus 1 times W is W. 1 divided by X, which is 9. One first. Josie. Nope. Jack. Nope. Josie. Come in. I have 8 squared. This is 8 times 8. 54. Okay, then I can do a multiplication and division. So 12 times 1/2 will end up being 12 over 2. What's 12 divided by 2? 6. Okay, then I'm going to do my division. 6 divided by 6 is 2. 64 minus 2 is. Okay, so sometimes you'll have multiple variables. You'll just have one variable and then tell you variable. Okay, which is kind of silly because they wasted more ink writing it this way than just saying 824 divided by 4. But you can practice, like plugging things in. Okay, so it is ready for you online. If you would like to do it in the book, it's odds again. Remember that. Okay, it would be page 149 and 150, number 15 through 35 on 42. Okay, yeah, I'm going to have computer, you can't. We'll work until Mario gets back in. I can explain what the art is. So, when you guys have a few minutes to work. Oh, he did? Yeah. So why did it like, hey, you're better.